Yeah, before we talk about machine learning with Scikit-Learn in the next lecture, let us briefly talk about object-oriented programming. That means Python classes. And that becomes very relevant very soon when we talk about Scikit-Learn, because Scikit-Learn is heavily based on object-oriented programming concepts. And at the end of this video, I will show you an implementation of k-nearest neighbors using the Scikit-Learn API, or basically the approach that Scikit-Learn uses for implementing estimators like classifiers. So yeah, we are going to talk about Python classes now, so to get a better understanding of the Scikit-Learn API, like I just said. And that will hopefully make everything kind of like easier to understand when we use Scikit-Learn in the next video. So here I created a very simple, naive vehicle class. So a vehicle could be a car, a motorcycle, or a truck, and so forth. So just visualize it as like some type of vehicle here. So we have a vehicle class, and how classes work is that we basically have the class definition here in this line, and then indented we have the different class methods. Class methods are very similar to functions. However, note that the first argument to each class method is a mandatory self here. So there is also a concept like static methods. However, we are just talking about regular methods here. So every method has to have a self here as the first argument. And the self here refers to the object itself. So you can think of a class as a cookie cutter that you can use to make or cut out cookies. If you have, let's say, this plate of dough and you have the star-shaped cookie cutter, you can apply this cookie cutter to different places on this dough, on this plate of dough, and then you can get these different cookies from there. So you can, these are not really nice cookies, but you can get multiple cookies. So the cookie cutter itself, that would be the class which you can use to make, or as a template to make these different objects. So the cookies here would be objects basically. So objects created from this class, or we sometimes also say instances of the class and stuff like that. So here the class, you can think of it as a template for making vehicle objects. However, let's not get ahead of ourselves here and see how what we have here in this vehicle class. So the first method here is the init method, and the init method is the so-called constructor, which will basically be executed when we create a new object. So if we have an assignment, for example, new vehicle equals, let's say, vehicle class. So if we call the class to make a new vehicle object, if we do this, then the init method gets executed. We don't have to explicitly call, let's say, vehicle class dot underscore init. This is not necessary. It automatically gets executed once we initialize a new object. So what do we have here in this init method? So this init method accepts one argument, the horsepower. Let's say the horsepower of the vehicle here that we have to define, because here we don't have a default value, we have to define it. And then there is an attribute here. So the attribute is horsepower. So we are basically assigning the argument provided to this method to an attribute. So this is an attribute. So if we create an object, if we created this new vehicle here, the new vehicle will have an attribute dot horsepower that we can then access to look up the horsepower. So here, when we create this, there should be a number, for example, I don't know, 1, 2, 3, something like that. And then if we access this attribute, it would return 1, 2, 3. It's just a way of attaching a value or a variable just to this object. So in the self means the object itself created from this class. So self gets translated to whatever the name of the object is when we create it. Yeah, and since we are running out of space here, let me forward one slide so I can talk about this a little bit in more detail, where I have a little bit more space for annotation. So yeah, here again for reference, I have what I had on the last slide, so you can take a look at this again. And now step by step, here on the right hand side is the code for instantiating a new object using the vehicle class. So the vehicle class was our cookie cutter, and this is our actual cookie that we create using the cookie cutter. So here we call that object car1, it's just an arbitrary name, and we provide it with the input in the init method. So if we create, or if we call the class here to create a new object, it will automatically execute what's in the init method, so in the constructor. So after we created the object, this one will be available, which got executed here. So creating this calls the init method, which we also call the constructor method. And then we can use all the other methods on the car object, which I will show you in the next slide. So here I'm calling now the horsepower to torque method, which I looked up on Wikipedia. It's just a method I implemented for converting between horsepower. It's a measurement of how, let's say, not fast but powerful a car is, and converting it to torque. So I put some calculation in here, and it will return the value, the torque. So it will convert the horsepower into torque. So we have to provide the rounds per minute for that. So that is something we have to provide. But internally, let me use a different color here. Internally, it will use the horsepower that we defined here. So the car, remember, has a horsepower attribute. So this is an attribute, the horsepower. It has an attribute that is internally used here when we call the horsepower to torque. And then it uses this one, so the RPM here, together with the horsepower attribute to calculate the torque. Now we can also define a method that modifies attributes. For example, in the next call here, I'm calling the tune motor method, which tunes the motor, so the car after tuning it has twice the horsepower. Amazing, right? That would be great if it works so simply in real life. Anyways, so yeah, now our car has twice the horsepower, so it should have, instead of 123, if you would print horsepower after tune motor, you would see 246 now for the horsepower. And now I'm calling the horsepower to torque method again. So you can see now it's different than before, because before our car had horsepower 123 here, and we tuned the motor, so it's now 246, so it kind of doubled the torque. So in this slide I just wanted to kind of go over the concepts behind class attributes and methods. So there are some methods that return values, and some methods, they don't return values, but they modify the object. So that's important to keep in mind. There are methods that return values that don't modify the object, and some modify the object. And actually we can't really, as a user, we can't really know what's going on. Usually this is hidden from a user. We as the code developer or the person who writes the code, we can of course see that, but usually the users, if you use something like someone else's library or code, you only see this part here on the right, and from here, from looking at that, you can't just see whether this modifies the object or not. So in that way, the only way to tell is, let's say, looking at the source code or the documentation. However, in Scikit-Learn, there are certain conventions for certain methods that do modify the object, and we will also then talk about this a little bit later. But for now, there are two more methods I wanted to talk about briefly. So there's the private method I had. So in Python there's a convention, the Python people in the Python community say, or as the saying goes, it's we are all adults here. So we are not restricting any access to anything in Python. So you can do whatever you want in Python. You can have access to everything in the Python library that you import. However, it's on your own responsibility. So if there are methods that the users shouldn't use, but if they want to, they can use them, then there's a convention to add an underscore in front. So this is a convention saying, hey, this method is private. Don't use that method. It's useful for developers, but not for you, the user. But if you really want to use it, go ahead and use it. It's just your own responsibility. If something goes wrong, it's not our intention that you use it, but please go ahead if you like. So that's what the underscore indicates, the underscore in the front. And you can just call the methods like a normal method, even though they have an underscore in front. It's just like a convention. It's not doing anything with the code, it's just a convention. Now there is a slightly stronger convention. It's using a double underscore, and that is if you have a very, very private method where you really want to hide that method from the user and you don't want that to show up, in certain documentation aspects and so forth. So there is this double underscore. And this one, again, like we said, we are all adults here. It's possible to access the double underscore methods, the very private methods, but it's a little bit more tricky to access those. So in order to access those, we can't just call the method like that. You will get an attribute error here. So it will tell you that, this doesn't exist, so we can't just call it like that. That doesn't work. So, but we are all adults here, so what can we do? So the solution to that problem is this little workaround where we put the name of the class here in front, and it's just like making the access a little bit trickier, but again we can access this method. So if you want to access a very, very private method, you will have to put the class name here in front with another leading underscore, and this way you can also access these very, very private methods. But in Scikit-Learn, or personally, when I write code, I usually never use those. I just use the simple underscore method, and usually that is sufficient in most cases. Another concept related to Python classes is inheritance. So I should have put that in the title, inheritance. So you can essentially inherit from a parent class. You can make a child class or children classes that are inheriting from a parent class. So for example, I can make a specialized car class that has some additional properties. For example, the car class, or all cars from the car class, have 4 wheels, and I could make a separate motorbike class where all the vehicles, all the motorbikes basically inheriting from the vehicle class will only have 2 wheels. So in that kind of way I can inherit all the shared properties from the parent class, but can make them more specific for specific objects from a child class. So here I'm making a child class that inherits from the parent class here. So it basically inherits everything from the parent. So what I'm doing here, in order to do that inheritance, I put the vehicle class here, and then I am calling this one here. So this one will cause the car class to execute its init method so that the horsepower gets initialized from the car class's init method. And then I'm adding another attribute here, the number of wheels. So I set it to 4 here. So then I can create a new car, now inheriting from the car class, but note that it still gets the horsepower here, because we are still using it here, and then we are calling that in the car classes init method. So even though we didn't set the attribute, we didn't set self.horsepower to horsepower, it's still available because that would be done in the parent class. And that is how it works. The rest is basically the same as for the parent class. yeah, to connect all the topics we just talked about, I wrote a very simple KNN classifier that follows the Scikit-Learn API. But of course, if you would look at the source code of the Scikit-Learn one, it would be way more complicated because it has all kinds of bells and whistles, like the KD tree, bold tree implementation, and many tweaks. I just wanted to make it as simple as possible so that I can fit it on one slide and talk about it in 5 minutes instead of 50 minutes. So yeah, but still the same overall concepts apply. So my KNN classifier has an init method, and it takes all the relevant arguments. So here I only have 2 hyperparameters. So here that would be k, the number of neighbors. For example, in Scikit-Learn it's called n neighbors, but it doesn't really matter. I just called it k. And then I'm having a distance function here. And then when the init method would be called, it would set or memorize, basically assign it to an attribute, the number of neighbors. And then if I don't provide, as a user, if I don't provide a distance function, it would use its own or the default distance function. In this case, it would be the Euclidean distance. So note here, I'm using this underscore. So this is a private method. I just wrote this method for the KNN classifier to use if the user doesn't provide a distance method. But there is no reason that the user should ever, let's say, execute this one. Of course, also you can see this is a very inefficient implementation. I think I gave you as a homework exercise to make this more efficient using NumPy. Anyways, so here I'm using a private method because there's no reason why the user should call this method. I'm indicating, hey, this is just internally used. Yeah, and then there are 2 public methods, a fit method, that's the training method, and a predict method. So that's doing the prediction once the training has completed. Now, let's take a look at the fit method, which is basically the training. What's going on here? So as you remember, the k-nearest neighbor classifier doesn't really do anything during training because it's a lazy machine learning algorithm. It's just saving the data set. So here we are just creating a copy of the features and the training labels, and we are assigning them to class attributes here. And then also all the unique labels. Note that I'm using an underscore here at the end. So what does that mean? Now So we didn't talk about the underscore at the end yet, and that is a Scikit-Learn convention. And usually in Scikit-Learn, the attributes with a trailing underscore, like that one, I'm writing it down because it's kind of an important point, and usually it's easy to forget. And in the past, by other students, it was a very common question later in the class because people forgot what the underscore was for. So this is a convention that attributes with a trailing underscore are available after calling fit. So that means these attributes don't exist before calling fit, and that is a way of distinguishing between parameters that we assign or hyperparameters that we assign here in the init method. In the init methods, we never use trailing underscores. We only use these for the attributes created in fit, and that is just a way of finding out whether a classifier was fit or not, and these are usually things that are created during training, for example these copies of the training set in this case. Now after training we can then call predict, and I don't want to go over all of this, but in predict, for example, we are calling again a private method, and this private method will find the nearest neighbor. So again, this is a method that the user doesn't have to execute, it's just internally used. All the user has to worry about is initializing a new object and then doing the fit and predict, basically. That's all the user has to do. And I think I have some more slides showing this. So actually one more slide. So here This is how we would use our KNN classifier. We would initialize it with a hyperparameter 3. We don't use a distance function, so it will by default use the Euclidean distance function. And then we call fit using the training set, so xtrain and ytrain. This is what we created previously in the last video. So this is these are the features, and these are the class labels. And then after model fitting, we can call predict here on the validation set, and these are the predictions by the validation set. And that is how the Scikit-Learn API works. Of course, this is a very simplified version, but yeah, what's important to remember is there's a fit method, there's a predict method, and these are available for all classification algorithms and all regression algorithms. Most of them also have additional methods, for example, score and transform and stuff like that, but fit and predict are the main ones. And then there's an arbitrary number of private methods, but we don't have to worry or think about the private methods. They're just there to make the application or implementation here, to make it more efficient, to make the code in fit, let's say, a little bit smaller. So we could have actually squeezed all of that code into this one, but it's just like refactoring. It's easier to write code where you have smaller special purpose functions, because then it's easier to debug the code as a developer. Okay, so that was a very short, brief crash course on object-oriented programming and Python classes, and a brief glimpse into the Scikit-Learn API. So in the next lecture, in the next video, we will talk a little bit more about machine learning with Scikit-Learn.